Oh, sorry, caught me out there. Better just leave my cup of tea there. Come back to that later. Time for another webcast. Here we go. Quick reminder then of what you've got to do for your webcast this week. Watch the video and make some notes, remembering to stop and rewind whenever you need to. When you finish watching the video and your notes are all complete, you've got to write a summary of what you've learned. That's not copying down my summary, that's writing down in your own words what you've learned from today's screencast. And then number 3, when you've finished, coming up with some questions that you're going to ask me when we get back to the lab. So let's go. Okay, so here's our objectives today. Now you can see they're all about evaporation and heat transfer by evaporation. So simply knowing about evaporation is what will get you a D in the level ladder, all the way up to being able to explain why clothes are drying fast on windy days is about an A. So let's go. So today's screencast will be able to answer all these questions. Here's some basics about evaporation. Well, evaporation is all about changing from a liquid to a gas. So a puddle drying up, a kettle boiling, something that gets spilt on the floor drying up. All these things are evaporation. Energy is needed when this happens to get from the liquid state to the gas state. It's called a change of phase, a phase change. Now whenever this happens, evaporation, it always takes some energy away from the liquid and it cools down the liquid. So we put a cover on a swimming pool to make sure that overnight, when no one's using the pool, the water doesn't evaporate, because as the water evaporates from the surface of the pool, it cools down the pool and people have a cold swim in the mornings. What about sweating? How does that manage to cool you down? Well, let's have a look. Let's watch this naked scientist and see if that helps.
In order to evaporate and turn into a vapour, the liquids need to absorb extra energy from the skin to enable the molecules to break apart from each other and change their phase from being a liquid and turn into a gas. And because this involves breaking bonds between the molecules, and breaking bonds requires energy, this energy is taken from the skin's surface, which cools it down.
That's better, sorry about that. So here we go. What we saw in the video there was that as the sweat evaporates from your skin, it takes energy away, and it mentioned a lot there about molecules. So let's try and find out a bit more about the forces between the molecules. Oh, let's have a look at the cup of tea first. Best way to keep it warm? Put a saucer on top to stop the evaporation. The evaporation cools it down much faster than heat getting out through the sides by conduction, for example. Let's have a look at this idea about the forces then. The main thing in this table to look at is this here, about the forces between the particles. So we're concerned with a liquid and a gas. Well, in a liquid, the forces are relatively weak. There's definitely forces there holding the molecules together, which is why it's a liquid and not a gas. Because in a gas, all the molecules are separated, there's no forces there. And that's the key to heat transfer by evaporation. In our pictures, all these particles are linked together by forces, and these ones are moving around, there's no forces between them. And to get from a liquid to a gas, it's going to require a lot of energy to break all of these bonds. Let's have a look. Okay, so this simulation is showing us now a beaker with some liquid in it. If I heat it up a little bit, now you can see the molecules are occasionally have enough energy to leave. The ones with the most energy are leaving, and as we heat it up and heat it up, more of the molecules have enough energy to leave and to become a gas. Let's have a look at another sim in a second. Oop, gone past it again. Let's have a look at the next sim. Okay. Now, if I restart this one, okay, here's all our molecules together. That's a solid. If I heat it up a little bit, we can see they've got more energy, the molecules have got more energy, the molecules have got more energy. they get to a point where the molecules are able to just move around a little bit. They're still touching, they're still connected by strong forces, but occasionally they can break the forces, and that means they can slip over each other. So this is a liquid. As I heat it up enough more, you'll see occasionally one of the molecules gains enough energy just to break all its bonds, like that one there. Now this is the process of evaporation starting to happen, that occasionally a molecule has enough energy to evaporate. Here we go, some of them are starting to escape altogether, and those ones are evaporating. So that's the process of evaporation. Quick summary. Evaporation is when a liquid turns into a gas, and it always cools things down. Because the gas molecules have got more energy, they need more energy to break the bonds from a liquid. You've got to break the bonds to turn from a liquid to a gas, and that's what the energy happens with. So evaporation is taking heat energy away from the liquid and cooling it down. Let's have a think about drying some clothes. Now, you should know that clothes are going to dry faster on a windy day, and the reason is all to do with a word called saturation. What's happening is not that the wind is speeding up the molecules or anything, it's just taking away damp air from around the clothes. Now, the air at any one time can only hold a certain amount of water vapour, and when it's full of water vapour, we say it's saturated. Now, next to the clothes, on the surface next to the clothes, the air quickly becomes saturated and it can't hold any more water. And that stops the water evaporating from the clothes. When it's windy, the damp air, the saturated air, is blown away and replaced by some drier air, and evaporation can start again, so the washing dries. Now, the opposite of evaporation is condensation. Funnily enough, the steam that's coming out of the kettle is the same temperature as the water in the kettle, 100 degrees C. But you might know, if you've ever leaned over a kettle, that a burn from steam is much worse than a burn from the hot water. Why is this? You might also know that when the steam touches something, it condenses. Hold a saucer or something over a kettle and you'll find that it's covered in water, okay, because the steam's condensed. Now this condensation, going from a gas to a liquid, is the opposite of evaporation. So rather than taking in energy, it's going to give out energy. And it's that energy that heats up your skin and causes the burn. Let's have a look at this on a diagram. Going from a liquid to a gas is evaporation, and it takes in energy. You've got to put energy in to boil the kettle, to turn it from a liquid into a gas. Going the other way round is condensation, and that gives out the energy, which is why steam burns are so bad. Okay, quick check on the objectives. You should be able to answer all these objectives with the notes that you make from today's video. Thanks very much for watching. That's all. Don't forget, make sure you make your own summary, check the objectives, make sure your summary meets the objectives, and write down some questions to ask for what to do next. Now, back to that cup of tea.